Dear students, in previous class we learned about some formulas and problems of properties of triangles. In this class we will learn some more problems on properties of triangles. So let us see properties of triangles. In this chapter we do some problems here in this class. So objectives of this class: on completion of this period you would be able to solve problems using sine rule, cosine rule, projection rule, tangent rule, half angles in terms of its sides. So we know all of these rules and formulas and with proofs also. In earlier classes we discussed. In previous classes we discussed. So on that rule we will do some more problems. So let us see. First question: in any triangle ABC, show that sine of C minus A by 2 equals to C minus A by B into cos B by 2. Solution: take C minus A by B, which is in the RHS. So first we will simplify that. C minus A by B, that equals to, C means from sine rule we know 2r sine C. So substitute in place of C by using sine rule, and same to A and B also. So 2r sine C minus 2r sine A by 2r sine B. Next, if we take the 2r common from numerator, we have like this. 2r of here you have to keep the bracket. So here bracket is not printed, but we have to keep it. So in the bracket we have to keep sine C minus sine A by 2r sine B. So 2r get cancelled. The remaining terms are sine C minus sine A by sine B. And in the numerator, if you observe, sine C minus sine A, it is in the form of sine C minus sine D. So sine C minus sine D formula is 2 cos C plus D by 2 sine C minus D by 2. So here, if we apply this, we can write 2 cos of C plus A by 2 into sine of C minus A by 2 by sine B can be written as a 2 sine B by 2 into cos B by 2. These formulas we already learned in compound angles and transformations. So you already know. Therefore that equals to A plus C can be replaced by 180 minus B. So 180 minus B by 2 means 90 minus B by 2. Cos 90 means sine B by 2. Therefore, in the numerator and denominator, sine B by 2, sine B by 2 get cancelled and 2 get cancelled. So in the numerator we have sine of C minus A by 2 by, and in the denominator we have cos B by 2. You can see here. On cross multiplication, C minus A by B into cos B by 2 equals to sine of C minus A by 2, hence proved. So here we have to remember, to show this problem, take the c minus a by b which is in the RHS. From that, if we simplify, we will get the required proof. So this type of problems are overall in our syllabus. We have 5-6 questions. So before going to exam, we must remember and we must see these problems, because if you remember these steps, so here if we take c minus a by b, we are getting easily required proof. So this type of problems, mostly 5 or 6 numbers, so questions are there in our syllabus. So remaining are, if you take LHS you will get RHS, or either if you took RHS you will get LHS. So there is no waste of time. But this type of problems, if you not remember the which term you have to take, if you forget it, that means it is a waste of time, and sometimes you may not prove. So remember this type of questions especially. Next question, second one. If a by cos a equals to b by cos b, show that triangle ABC is isosceles. A by cos A equals to B by cos B. On cross multiplication, we get B cos A equals to A cos B. So B into cos A means from cosine rule, we can write B square plus C square minus A square by 2BC, that equals to A into cos B. We can write same again from cosine rule, A square plus C square minus B square by 2AC. So here if you observe, BB get cancelled and 2C's remain in the denominator, and here also AA get cancelled to the right side. Again we have 2C in the denominator. So both the denominators are same, so the denominators get cancelled, and in the numerator if you observe, both sides c square is there, so c square also get cancelled. So remaining terms are b square minus a square equals to a square minus b square. Next, if minus a square goes to the right side and minus b square is comes to the left side, then we get 2a square equals to 2b square. Here we are interchanged both, so no problem, there is unchanged. So 2 get cancelled, then and squares also get cancelled. So therefore we have a equals to b. So two sides are equal means it is a isosceles triangle. So iso means two sides should be equal in a triangle. Okay. Here we shown a equals to b. So that means two sides are equal. Therefore it is said isosceles. Next question. Show that in any triangle ABC, sigma of AC into cos square b by 2 equals to s square. LHS, take LHS, that is sigma into AC into cos square b by 2, that equals to AC into, here we are expanding, that means from short form to we are expanding as a full form. So sigma means we already know the cyclic summation. So in a triangle ABC, So up to C we have to write. So according to the term we have to uh, cyclic summation we have to write. See how we will write. AC into cos square b by 2 is given. So after A we have B. So B, for C A comes. So B into A. See here you can see the third term. So BR AB is same. So AB and B after C. So cos square C by 2. And now see the middle term. From third term we will write middle term. So after A we have B. After B we have C. And cos square C after we have cos square A because C after A. So totally from one term we made two terms because in a triangle total 3. So already one term is given means we have to form from that term some more two terms and we have to add them. So this is called cyclic summation and it is in the short form we wrote sigma. Clear? So already I told you in previous class also. Again I am explained here. Next, cos A by 2 equals to, we have the formula under root of s into s minus a by bc. And similarly, cos B by 2 equals to under root of s into s minus b by ac. And cos C by 2 equals to under root of s into s minus c by ab. So squaring means square root get cancelled. So cos square a b by 2 is replaced with here s into s minus b by ac, and plus come to the second term bc write as it is, and cos square a by 2 is replaced with s into s minus a by bc, and last term plus ab into cos square c by 2 is replaced with s into s minus c by ab, and in each term numerator and denominator get cancelled and remaining terms are s into s minus a plus s into s minus b plus s into s minus c. So here in each term s is there, so take s common and remaining keep in a bracket. So take s common and open the bracket and write s minus a plus s minus b plus s minus c and bracket close. Here brackets are not kept, so printing mistake. So u and v have to keep them in bracket. So s of s plus s means 3s, and if we took minus common from a b c, then we can get minus of a plus b plus c. So these are all again kept in a bracket. So s of 3s minus a plus b plus c means 2s, since s equals to a plus b plus c by 2. So 3s minus 2s means s. S into s is s square. So this is the RHS. So from LHS we got RHS. Hence we showed. And fourth question. Show that in any triangle ABC, sigma of a cube into cos of b minus c equals to 3abc. So here solution is take LHS. So LHS is sigma of a cube into cos of b minus c, that equals to sigma of a cube can be written as a square into a cos of b minus c, that equals to sigma into a square into a can be written as a 2r sine a from sine rule. Here sine rule is given, you can observe, and cos of b minus c as it is. Then next step, that equals to sigma into a square into r into 2 sine a. A means we can write in place of a 180 minus b plus c. So 180 minus b plus c means second quadrant. In second, sign is plus, and 180 means sign unchanged. So sign as it is and sign of b plus c. So here b plus c should be in a bracket into cos of b minus c. And next step, that equals to sigma into a square into r into 2 sine a cos b. It is in the form of 2 sine a cos b. So if we apply the formula, then we can write it is a 2 sine a cos b equals to sine of a plus b plus sine of a minus b. So sine of a plus b means here a means b plus c and b means b minus c. So if you substitute, see here, sine of b plus c plus b minus c and bracket close, and plus sine of b plus c minus of b minus c. If you multiply with minus, it becomes minus b plus c and bracket close. Here closed brackets are not printed, but we have to keep. Next, that equals to sigma a square into capital R, and here open the bracket. So CC get cancelled, then b plus b sine 2b. And in the second term, bb get cancelled, so CC is 2c, therefore sine 2c. So sine 2b and sine 2c should be kept in a bracket. Here brackets are missed. Next step, sigma a square into r into sine 2b can be written as 2 sine b cos b from compound angles formulas. Similarly, sine 2c can be written as 2 sine c cos c, that equals to sigma into, or sigma of a square into, take 2 common or multiply with r to the two terms, with two terms. It means in the bracket there are two terms, so r is, if we multiply, then r multiply to the each and every term of the bracket. So in bracket two terms, so r multiply with two terms, so then it becomes 2r sine b cos b plus 2r sine c cos c. Sigma a square into 2r sine b means we can write b, small b, from sine rule. So b cos b plus 2r sine c means small c. This is also from sine rule, and cos c as it is. So here b cos b plus c cos c should be in a bracket. Here bracket is missed or not printed. Next, Here I am expanding the sigma. That means I am writing as a cyclic summation. So you know how to write from base given term. Based on given term, we have to make some more terms. That means totally triangle have three so sides and three angles. So three terms should be there. So one is given. From that one we have to frame two more terms, and that terms are comes based on cyclic. So I think you got the point. See here, first term as it is written, and after a square it should be in the bracket, and a after we know the side b, so b square into, and in the bracketed terms also we can write b after c, so c cos c plus a cos a. So here showing like the order is shuffled, but the meaning is same, plus c square into again a after b, so b cos b plus a cos a. So here sigma is expanded, so again we should not write sigma, because from short form we had wrote full form. So that is sigma is fulfilled here, so sigma removed in this step, and taking a square b square c square inside the brackets. Okay, that means we are multiplied with a square with the terms to the bracketed, which are in bracketed or inside the brackets. Okay, then it becomes a square into b cos b plus a square into c cos c, and b square into a cos a plus b square into c cos c plus c square into b cos b plus c square into a cos a. And after that equals to, if we took ab common, then we get a cos b plus b cos a. So that means where ab is associated with the terms, from that terms we are taken ab common. So here if we have the first term is a square b, and third term is also involved with ab, so first and third we took ab common. Like similarly in the second term we took bc common, so bc is taken from 4 and 5, 4 and 5th terms, and remaining terms we took ac common. Then from projection rule, we can write a cos b plus b cos a equals to c, and similarly c cos b plus b cos c equals to a, and c cos a plus a cos c equals to b. So therefore it becomes abc plus abc plus abc, that equals to 3abc. So this is the RHS, hence we proved. And next question, it is number 5. In any triangle ABC, show that a cos a plus b cos b plus c cos c equals to 2 delta by r. So in solution, take LHS. A cos a plus b cos b plus c cos c. From sine rule, small a is replaced with 2r sine a, and small b is replaced with 2r sine b, and small c is replaced with 2r sine c, remaining as it is. Next, that equals to r into, and write the 2 near sign. So 2 into sine a cos a plus 2 into, and one more thing here, in the each term r is there, so take common, take r common from three terms. So r of, so here bracket should be kept, but here not printed, so r of, means here we have to open the bracket and write 2 sine a cos a plus 2 sine b cos b plus 2 sine c cos c, and bracket close, and r of 2 sine a cos a means sine 2a plus sine 2b plus sine 2c. So bracket should be there, so we have to keep there, printing is not came. Next, that equals to r of, see the first two terms, it is in the form of sine c plus sine d, so we are applying here 2 sine of c plus d by 2 into cos of c minus d by 2. So in place of c, write 2a and d with 2b and plus sine 2c. So here bracket again given, no problem. Next, r of, again here brackets removed but not printed, so we have to keep it bracket. So 2 into sine of a plus b into cos of a minus b plus sine 2c, because in the angles numerator if you took common 2 and in the denominator also 2, so 2 to get cancelled. Next step, so 2 sine of a plus b, it should be in a bracket, and cos of a minus b should be in a bracket, plus sine 2c, we can write 2 sine c cos c from compound angles formulas we already know. And see here, sine of a plus b, we can write sine of 180 minus c, that equals to sine c, and cos of a plus b equals to cos of 180 minus c, and it should, that is equals to minus cos c, because in the second quadrant cos not lies, so the negative sign comes. And next step, r of sine c into cos of a minus b should be in a bracket, plus 2 sine c cos c, and r of sine 2 sine c, if we took common from both the terms, and bracket should be open, and cos of a minus b should be in a bracket, plus cos c, and bracket close. Here brackets are not given, we have to kept. Then next step, r 2 sine c cos of a minus b, cos c is we can write minus of cos a plus b. Already I explained you how cos c is equals to minus of cos a plus b, because cos of a plus b equals to, we know, minus cos c, and if you multiply with minus on both sides, then cos c equals to, we have minus cos of a plus b, so cos c is replaced with minus of cos a plus b. So r into 2 sine c, and cos a minus b minus cos a plus b equals to, we have 2 sine a sine b, so right there, and that equals to r into 2 sine c into 2 sine a sine b. So 2 into 2 4 r, and sin A, sin B, sin C, and sin A is replaced with A by 2r from sine rule. Similarly, sin B is replaced with B by 2r, and sin C is replaced with C by 2r. So in the numerator we have 4r. From denominator 4r we should be cancel with numerator, and the remaining terms are 2r square. So see here, ABC is replaced with 4r into delta, and so directly don't cancel. First see in the denominator 2r 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 means 2r 2r whole cube, here bracket is missed. Okay, next ABC is, we can write 4r delta. Delta means area of the triangle. So 4 into 4 16, and in the denominator 2 cube means 8. 16 by 8 means 2, and delta by r. So this is RHS. Hence we proved. Next question. Number 6. In any triangle ABC, show that cot A by 2 plus cot B by 2 plus cot C by 2 by cot A plus cot B plus cot C equals to A plus B plus C square by, A plus B plus C whole square, I think it is bracket is said here, by A square plus B square plus C square. So first in the solution, take numerator part of the LHS, that is cot A by 2 plus cot B by 2 plus cot C by 2, and cot A by 2 we can write S into S minus A by delta. Similarly, cot B by 2 we can write S into S minus B by delta, and cot C by 2 we can replace with S into S minus C by delta. In each term, S by delta is common, so take S by delta common, then we have S plus S plus S, and minus is also, if we took from ABC terms, then we have minus of A plus B plus C and bracket close. Then S of 3S minus of A plus B plus C and bracket close by delta. Then S of 3S minus A plus B plus C means 2S. So 3S minus 2S by delta, that is S into S by delta, that equals to S square by delta. Therefore S is, we know, A plus B plus C by 2. So square means whole square. 2 square means 4. Here bracket is missed. We have to keep it in a bracket. So consider this as a equation 1. And now take the denominator of the LHS. Denominator is cot A plus cot B plus cot C. And here cot A can be written as cos A by sin A, and cot B also cos B by sin B, and cot C also cos C by sin C. From cosine rule, cos A can be written as b square plus c square minus a square by 2bc, and sin A is written as a by 2r plus cos B a square plus c square minus b square by 2ac by b by 2r, and cos C a square plus b square minus c square by 2ab by c by 2r. So if the denominator goes to upside, that means near the numerator, it becomes reverse, that is 2r by a. So 2 get cancelled and r by abc. So this r by abc is common in 3 terms. So take r by abc common from 3 terms, and we have like this. Here brackets not kept. So r by abc of b square plus c square minus a square plus a square plus c square minus b square plus a square plus b square minus c square, and bracket close. So that equals to r by abc of a square plus b square plus c square, and that equals to r by 4r delta, and a square plus b square plus c square, and that equals to a square plus b square plus c square by 4 delta. And LHS is, and here now to prove, take LHS, that is cot A by 2 plus cot B by 2 plus cot C by 2 by cot A plus cot B plus cot C. In the numerator, we have already solved, and numerator is equation from 1. Numerator is written as a plus b plus c whole square by 4 delta, and denominator can be replaced with a square plus b square plus c square by 4 delta from equation 2. So 4 delta cancelled, so remaining terms is here a plus b plus c whole square by a square plus b square plus c square. This is RHS, hence we proved. Next question, number 7. In any triangle ABC, show that if A, B, C are in AP, then cot A by 2, cot B by 2, cot C by 2 are also in AP. So solution is, given ABC are in AP, that is 2B equals to A plus C. Consider it as equation 1, and we need to show cot A by 2 plus cot C by 2 equals to 2 cot B by 2. So take LHS, that is cot A by 2 plus cot C by 2. Cot A by 2, we have cot A by 2 can be written as s into s minus a by delta, and cot C by 2 is replaced with s into s minus c by delta. So in both the terms, s by delta is common, so take common, and s by delta if we took common, remaining is s minus a plus s minus c. So again minus, if we took the common from two terms, minus of a plus c is there. So s plus s, 2s, and a plus c equals to 2b according to the condition. So here 2b is written. Next, 2 common from both the terms. So take 2 common and 2s into s minus b by delta. So 2 into remaining part is we can write cot b by 2. So this is RHS. Hence we said cot a by 2, cot b by 2, cot c by 2 are also in AP. Hence proved. Next question, number 8. In any triangle ABC, if 1 by a plus c plus 1 by b plus c equals to 3 by a plus b plus c, then show that angle C equals to 60 degrees. So here if means condition, so solution is given that condition is taken 1 by a plus c plus 1 by b plus c equals to 3 by a plus b plus c. If we took LCM, we have like this: b plus c plus a plus c in the numerator and a plus c into b plus c in the denominator. So here brackets are missed in the denominator, we have to keep. That equals to 3 by a plus b plus c. Cross multiplying here we are doing. So a plus b plus c into a plus b plus 2c equals to 3 of a plus c into b plus c. And next step is also same. And if you multiplied in LHS and also in RHS, we have this step. So you know how to multiply a in the first two factors, first factors of the a multiplied with second factors of the each term, and after that b also same continues and c also same continues. So 3 into 3 means 9 terms comes. In the right side 2 into 2 means 4 terms comes. Okay, and after addition simplification we get, see here, the right side parts, if we took left side, the remaining right side part is null, that means 0. So we get, after simplifying like this, a square plus b square minus c square minus ab equals to 0. If minus ab goes to right side, it is plus ab. And here dividing both sides by 2ab. So then it becomes, right side is 1 by 2 and left side it is in the form of cos c. So cos c equals to cos 60. So cos get cancelled, then c equals to 60 degrees. Hence we proved. A summary. In this lesson you learnt solving the problems using properties of triangles. That is sine rule, cosine rule, projection rule, tangent rule, half angles in terms of its sides. So let us see the quiz questions. These are easy and you can easily answer. Cos C equals to, if you know the cosine rule, you can say the answer, that is B. And tan of b minus c by 2 equals to, so tangent rule, that is answer is D, b minus c by b plus c into cot of a by 2. Next, frequently asked questions. So here some questions are giving, so and that questions are came in exam also. So if you do these problems, you will get confidence, and you can easily remember the formulas, because while you are doing means, in that solution you have to substitute the steps with formulas. So if you are substituting means, you have to read the formula, you have to see the formula which is expressed in another terms. So you are doing problems means you are knowing formulas, you are writing formulas, you are remembering formulas. So do more, as much as problems, as many as problems, and see the example problems if you have any doubts, and show that means that is easy questions, because question is there and answer also there. Just you have to use the formulas according to the proof what they are asking in RHS. And here some assignment is given for you. So 3 questions are given, and from exercise you can do more questions, problems. And if you have any doubts, ask me or mail me. And one more thing, while watching the video, you can open the PPT in another device. Every video is having a PPT. So if you want PPT, I can send PPT separately. So then if screen clarity issues is there, you can overcome by seeing PPT. And PPT is very clear, and till you have any doubts, still you can ask me or mail me and clarify your doubts. So have a nice day.